All right, continuing on with Jupiter. So we're talking about these storms here. This is a cloud motion movie that they made. Cassini was the mission that went to Saturn, and it shot pictures of Jupiter for many, many days in a row. And so they put them all together into a movie, a very short movie. It's only like 7 seconds. But there's no spot to synchronize on, so they said, well, let's just synchronize on the red spot. So they said, we're going to keep the red spot here as we make this movie, and we're going to watch how the clouds move with respect to it. So just watch this closely here, and you'll see how the equatorial region is moving this way, but the one above it seems to be moving this way, and then these are going back again. Sorry. It's a problem when you have an 8-second movie. It doesn't last very long. And so you can see the motion varying as you go up, and you see even the spots moving in the top and the bottom again. All right, that's enough of that. All right, so that's what we see with Jupiter. Here is a picture. This is just one of my favorite pictures because it's a really cool picture here. This was a Cassini picture again too. This is the red spot. This is the moon Io, and this is the shadow of Io on top of the clouds as it flew by. I mean, that was just kind of a cool picture. And you can see such detail in the clouds and all this turbulence here. As you have one flow going this way, one flow going this way, you can imagine that the flow in the opposite direction is going to create a lot of turbulence at these edges here. And then the flow is more uniform down the middle here, and you get turbulence again wherever the edges of the clouds bands occur. We do see auroras on Jupiter because Jupiter has a strong magnetic field. Particles from the sun get filtered down. Once they hit the atmosphere, they start to make it glow. Because it's 5 times further away from the sun than the Earth is, it doesn't get quite as many particles. The particles have spread out more, but it still has significant aurora. It also has lightning, because you have water vapor and you have clouds moving against each other, which strips electrons off, which is why you have lightning and thunder. And so you would have that on Jupiter as well. In fact, we've detected it on Jupiter. It does have a ring. Now, Jupiter's ring is really, really thin and hard to see, and from Earth it's almost impossible to see. But they took a picture. What they did is the mission flew behind. In fact, this was Voyager 2, I think it was. Flew behind Jupiter, so the sun is on the backside of Jupiter, and turned around and shot this picture. So you can see the sunlight coming through the edge of the clouds, essentially being refracted, and that's when the ring showed up. Now, it probably would have a more extensive ring system, but because of its innermost moon, Io, it's right at the edge of the ring system. It kind of disrupts it so it doesn't have a thick ring system. But it does have a ring. All right, one of the cool things that happened to Jupiter, cool because it didn't happen to us, is back in 1994 or 95, these guys found this comet. The guy's names were Shoemaker-Levy, and the comet was named after him. In fact, it was Shoemaker-Levy 9. Technically, it was the 9th comet they found. So they were out there, these were amateur astronomers that were looking at, and they found this object, this comet out here, and they said, whoa, that looks kind of strange. Here was Jupiter, by the way, and they found it right by Jupiter. Because when they looked at it, they realized it wasn't just a comet, it was a whole string of them. And then the Hubble took this picture of it. It's actually multiple pictures put together, showing, yeah, there was a whole string of comets. What had happened was, the comet was coming in to go around the sun, like this, which it probably had done many times before, but it got so close to Jupiter, when it got by Jupiter, Jupiter's poling on it actually ripped it apart into all these pieces, and it changed its orbit so that it came around, got sucked into Jupiter's field, and then crashed into the backside of Jupiter. Now, from the Earth, when we were looking at Jupiter, so here's Jupiter, the impact site was right here. But this is the direction towards the Earth. So we couldn't directly see where these impacts were occurring. It was actually around the back side. But what they realized was that these impacts, each of these chunks of material was about a mile across, like several kilometers, the bigger ones to smaller ones. And notice there's like 20 some different ones. And they create, when it hits, it creates a mushroom cloud, just like you see when you blow up a nuclear explosion. And that cloud of material could actually rise up over the edge of Jupiter so you could see it. And then Jupiter rotates so fast that within a few minutes later, after Jupiter has rotated, we could see the scars. So this is the actual impact here. This was taken from Earth. This is Palomar telescope. This was the big one I was telling you about. And then here, this is as soon as it rotated around, you could see this scar in the atmosphere where the particle hit. So this was kind of a cool thing. This is the first time we'd ever seen an object hitting another object. And the nice thing is they discovered this months before it was going to hit. And so everybody knew when it was going to occur, and all the telescopes in the world were watching Jupiter at the same time. So this is a picture from the Hubble Space Telescope showing, you can see, actually I think time goes this way, you can see this cloud rising up over the edge of Jupiter, and then it starts to disperse back down. Now it did it in different colors or different filters right here, so it switched filters and take another picture as the cloud was rising up over the side. Here it is showing what the scar looks like. It was 1994. I can't remember the exact year, but 1994, once it rotated around, this is what was left. This is the debris field here. So all that energy went into Jupiter and the whole thing dissipated because, remember, Jupiter doesn't have a solid surface, so it didn't impact anything. It just created this shock wave as it came in and blew up in the clouds and created this pattern you see here. This is in green light, so it appeared dark in our visual spectrum, but in methane, this was actually bright, which means it was heating up. It was energy put into the clouds of Jupiter. And remember, keep this in perspective, that's about the size of the Earth. So that impact site there created this region on Jupiter that was about the size of the Earth. From a 1 kilometer, just over a half a mile across object hitting the atmosphere. I guess when you see stuff like this, it's not hard to imagine that the asteroid impact was what took out the dinosaurs. Now, here it is again, one's flipped over from the other. But over time, the problem was there were 20 pieces, so one would hit, Jupiter rotated, another one would hit, and it was kind of like boom, 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 and for about a day, stuff kept bombarding Jupiter, all at the same southern latitude here. And so these are all scars from different impacts over time. Now, those scars lasted for about a month or so, and then they slowly faded away as the clouds mixed up, and then they went away. And we thought, wow, that was such a cool event, it probably didn't happen much. Well, just a few years ago, an amateur was taking pictures of Jupiter, and all of a sudden it saw one of these marks, and we realized, guess what? Jupiter had been hit by something. And so we're thinking maybe this happens more often than we thought. That maybe it gets hit by these things once a decade, we just hadn't noticed before. All right, and that's all I have for Jupiter.